Hello, good morning, everyone. I hope you are doing well. Okay, my name is Mauro Cagnorio. Some of you already know me. I'm the sales manager at PAT Group for EMEA region. Yes. As you may know, PAT Group it's a multidisciplinary group of companies specialized in the equipment manufacture, analyze, advise, and implementation of production projects, and technological services. In this opportunity, we are going to initiate with this first of 6 webinars, which is called Introduction and General Concepts of Pharmaceutical Production. Before we start with the webinar, and we will wait 2-3 minutes to allow everyone can access the meeting. Yes. Today we have more than 100 participants in this webinar. Yes. So we will start with this video again. Please be sure that you can hear the noise and the sound, and everything, and then we'll start with the presentation. Yes. Welcome everybody. We still have people that just access to this first session of the webinar, so welcome to all of them. Before we start with this first webinar, I would like to inform you the terms for this session. Yes, it's important to mention that your headphones will be shut down to avoid interruptions. Yes. And in case you have questions or comments during the presentation, we will proceed on the following way. You can see on the lower corner of the menu, there's a button under Activities option, and then you have to press Questions and Answers button. It's the last one, it's the fourth option. Once that the question or comment has been formulated, we will answer it during the intervals for this purpose. We will stop first at the middle of the webinar and then at the end. Yes, and all the questions that are not answered during the webinar, we will do it by email. And in case you also have more questions after the webinar, you can get in contact with us, or you can send us an email to info@patgroup-sa.com. Okay. Now it's already 9:06 here in Spain. It's time to start. So please let me introduce you to the pharmaceutical degree, Mr. Gabriel Porto. He's our president and director at Ecovida PAT Group. Gabriel has more than 30 years experience on the pharmaceutical fields in areas like R&D, regulatory affairs, quality assurance, quality control, and manufacturing. He has international experience, now more than 10 years already working at Ecovida PAT Group as a director. So, Gabriel, please, welcome.
Well, hello, everybody. Thanks, Mauro. Thank you all for attending our first webinar. In this opportunity, it's a pleasure to introduce you a great friend of mine, a great person, the professor and pharmaceutical degree Arturo Oya, who is in charge of this dissertation today, right? So Arturo is a very expertise pharmacist with a large experience in R&D and production area, with more than 30 years of experience in Bao Laboratories, a prominent pharmaceutical company in, among others. No? It's a pleasure and believe me of a great benefit to listen to him carefully in this exposition, right? So please, Arturo, it's your time. Thank you very much.
Thank you, Gabriel, for my introduction, and good morning and welcome, everyone, and thank you for taking time to hear our first webinar about the pharmaceutical technology of a solid dosage form. First of all, I want to share with you the presentation. Here we have the one. This is, let me show you in the presentation mode. Please, is it okay? Can you see the presentation?
Perfect. Yes, yes, we can see.
Okay, okay. Thank you. Well, today, first of all, we have these 6 webinars. These are the contents and the data. And today the webinar will give an overview of the pharmaceutical oral solid dosage production. Let's say the tablet production mainly. First of all, I want to show you this global process that is a process that implies this transformation, powders to tablet coated. And so we try to give you a comprehensive vision of production pointed, this is very important, this question, pointed to product quality, very important, and process efficacy and efficiency. This slide shows the 3 steps, the 3 principal steps required to transform API and excipient in tablet coated. These 3 steps are, the first is produce an intermediate product. We say intermediate product, the blend of granules or powder that will be tableting at high speed. And then the third step is the tablet coated to finish the product. In subsequent webinars, we will deal with the different unit operation that we need to do in order to produce the intermediate product, in order to tablet in the powder, and in order to coat in the tablet. But in this moment, let us start with the classification of technology to produce this intermediate product. Very important step, because if you obtain a very good intermediate product with good attributes, the production will be fine. These technologies have 3 general processes. These are direct compression powders, dry granulation, wet granulation. I know you know these these principal steps. Okay, direct compression is the blending of powder by tumbling in the vessel or convection using a high shear mixer. Dry granulation means the compaction of the powder using a roller compactor, the first election, and slugging could be another possibility using the machine press, of course. And wet granulation, the main way to wet granulation is by shear. By shear is the principal opportunity, and we have to do by high shear or low shear. Well, before we want to show you this global survey around the world that show the percentage of each of these technology. As you can see, wet granulation is the most used technology in the world, following by direct compression. This big difference in favor of wet granulation is due to reason of the feasibility, since the most desired technology for us, although not always possible, is direct compression. And why is not ever possible direct compression? Well, you know that many formulas have high percentage of API with bad or very bad properties of flowability and compactability, and in occasion have very low dose that requires to obtain good uniformity of the API. So in these cases, it's very difficult obtain this by direct compression. So we need to use wet granulation in high share. This slide is the setup of the production line by direct compression, the very simple, fast, and economical, but not always used for the reason I said before. In this complete line, API and excipient are milled through a conical sieve mill with low energy in order to reduce lumps, aggregates, and then blending the powders in this kind of tumbled equipment. In this case, is an IBC, so intermediate bulk container tumbling vessel, and this blending is then low in the hopper of the tableting machine in order to produce at the highest speed possible, and these tablets are then coated in a totally perforated sided ventilated pan. This is in short the mechanism. Another unit operation is in the line of wet granulation. IPI and excipient are, first of all, dry mixed in the high share granulator, and then this wet granulation, of course, is with water, with alcohol, or with blending of water alcohol. After the wet granulation, we need to dry in fluid bed dryer to obtain the appropriate moisture content of the granules. And after this, we need to round the granules in order to reduce the distribution of the particle size distribution. After this, we need to blend these granules with the extra granular component, and then lubricate with stearate, magnesium stearate, or another stearate on another lubricant, in order to tableting at high speed. And then, of course, we need to coat in the tablet. Then we have the line of dry granulation. In dry granulation, we put the API and excipients into the blending machine, blend the components, and then we make a compaction, what means introduce mechanical energy to transform powders in briquettes, in tablets, and this compactor have a milling here in this position that ground the granules, then grounded the tablets or the briquettes to produce the granules. These granules are put in the IBC, blending the time, adequate time, lubricated, then tableting and coated. So this is in a short the steps we need to obtain for different general process, the intermediate product that will be tableting and coating. Well, in this slide, it shows the characteristics and attributes to be in mind in order to choose the pharmaceutical equipment. For me, for us, this is a very important aspect because the chosen equipment must produce the highest quality product at the highest speed. This is a very important question. And of course, the equipment that we choose must be instrumented with sensor devices that allow the process automation. It's very important, this question, the automation of the process and the data acquisition, because we need to document it, the process, all the process, because to GMP law. Here we have at the left, in this square, 16 parameters or attributes like structure, durability, after-sales service and parts, warranty, reliability, unit operation quality. This means functionality of equipment. Ergonomic aspect, very important because we need our people works in the best condition. Sensors and automations. Changeover is a very important question because we need to reduce the changeover time, the setup, the cleaning, the downtime. Of course, the cost is another question we need to try to evaluate during the selection. Speed of unit operation, very important too. Validability, and other question is online adaptability. Our equipment have to be possible to have versatility to align in different ways. Another question to be in mind is if the equipment have a user experience is very important. Digital capacity, acquisition of information, and of course scalability. Scalability because the galenic or the development in the laboratory must scale up at the production plant. So these are perhaps the more important. Unit operation quality, that the equipment produce a good operation unit that give us a quality product. Of course, the unit operation speed, we need to work at high speed possible to have sensor and automation in order to have the best performance in the process. Data acquisition for documentation, scalability, and versatility in order to adaptability. So these are questions important to be in mind. And the next question is which parameter we need to be an approach of the selection of the equipment. So in this following slide, the purchase of pharmaceutical equipment will focus it considering the factor OEE approach. Perhaps you know this acronym OEE means overall equipment effectiveness. And what means that acronym? Means it's an index of efficiency and efficacy. In this paper, American Pharmaceutical Review on 2017 said, acquire equipment and implemented it effectively it becomes a strategic imperative no pharma manufacturer can avoid. This is a very important question because you have to be in mind that you need to measure the efficacy and the efficiency of the machine you choose. The process and manufacturing community understand this factor, OEE offer a solid foundation for measuring or scoring operational excellence. And what does OEE means? Is the combination of availability of the equipment, the performance of the process, and the quality of the product. To be in mind this, we can look this formula where we see that OEE is equal to the product of availability of the equipment, the time you have the possibility to use the equipment, by or times performance, the process. The process must be conducted at high speed. This is a very important question. Of course, times quality, because better the quality, better the performance. Of course, availability means the real operation time divided total operation time. Of course, B divided A is ever lower than 1. Of course, performance of the process is real process speed divided optimal process speed. Of course, again, this is less than 1. And quality is the real quality production, F, divided total production, E. And again, this is not 1, but lower than 1, because we not ever we have the availability of the equipment is not 100% the time, because equipment failure, because configuration. So the availability of the equipment is reduced, and the performance, the process, need to be at high speed with minor stops, and the quality of the product need reduce the process defect and enhance the yield. So if we taking apart the availability of the equipment, because availability of the equipment depends on
Sorry, Arturo, I think your microphone is blocked.
You are mute.
You're mute. Arturo?
Yes. Now you have.
Yes. Now we can hear you.
Now, okay, but you lose part of the presentation.
Yes, the last 30 seconds.
Yes.
Okay, let me. Okay, you look this.
Yes, we can see your screen.
Okay, excuse me.
Yes, just there. Yes.
Okay. Look, the very important question in the C factor of OEE availability, we can take apart and put the attention in performance and quality. Performance and quality means that the performance is given by the speed operation. So if we increase the speed operation, we will have a good performance. Of course, we need to reduce the minor stop. In order of quality, we have to produce the lower defects of our product and increase the yield of this quality. If we obtain this quality high and the performance high, we will have an OEE of a good number. In order to give you an idea of the figure, the number of OEE, I want to say you that the ideal OEE, of course, is one ability, 100% of availability, 100% for performance, and 100% for quality. But this is not real possibility. Normally, in the industry, in the global industry, OEE is lower than 0.5, is lower than 50%. In the pharmaceutical industry, this is lower than 0.4, 40%. So, this is a global number, but it's very important to be in mind this question. So, and now I want to show you who's just a process time factor that means the performance.
Arturo, if
Sí.
you will mind, I would like to stop until here because we have some questions from our attendees, and it will be good to answer now. Yes.
Okay.
Please remember that to make questions during the webinar, there is a button on the right corner. Yes, and you have to press there. It says activities, and then you have, well, I have in Spanish, it says preguntas y respuestas, but it is questions and answers. Yes, so you can please make your questions there, and then we will reply. The first question that we have, yes, it came from Mr. Mabuda from Hikma, and he's asking if we will share these presentations with you. Yes, definitely. Between today afternoon, tomorrow, we will share with you all this presentation, and then we will also upload this video at our YouTube channel between 10 and 14 days. Yes, so you can see it on the future. Yes. Then the second question that we have, Arturo, and it's related to the presentation. It's well, it says, how can I identify the appropriate equipment for my products and processes?
Okay. We need to put the attention in this aspect that I referred before. When we try to choose equipment, we need to see the characteristics, the functionality characteristics, and pay attention into the speed of the operation, the functionality of the operation, and if the equipment meet these two conditions, it's possible that the efficacy and the efficiency of this equipment will be good and comply with your needs. The equipment you choose must have the very quality in terms of mechanism of produce the unit operation. A granulator, a fluid dryer, a compactor, a tableting machine, a coater, the operation. And the other question is the speed, because we see in the market that a lot of brands have or low speed or not good functionality. These are two aspects very important for me. The two main question to be in mind.
Thank you very much, Arturo, for your explanation. We have another question, in this case from Nasir, and he says 0.5 OEE seems very low. What are your basis of this number? As normally we work in pharmaceutical industry on more than 0.7. Otherwise, it will be a total loss of to organization. Yes.
Yes. In the industry, not only pharmaceutical industry, food industry, or another industry, the OEE always is lower than 1, always, because the factor of availability of the equipment. Some industries have very good performance because they use a submaximal speed, so the factor performance around 0.8, 0.7, and the quality in this industry are 0.9, 0.8. So when you multiply 0.7 with 0.8, you have a factor OEE of 0.56 or 56%. In pharmacy, in the pharma industry, the figures we see in the papers or in the reports are lower than 0.5. It is natural. 0.5 of OEE is a very good OEE. It's a very good OEE. 0.4, 40% of OEE is a very good too. Of course, we need to try to optimize the performance, try to optimize the quality. These are the two factors that we in PAT Group point, that the performance of the equipment, the speed, be the best, and the quality be the best too. If we obtain these two factors, then we depend of the program. In other words, you depend of the availability, the equipment.
Arturo, let me complement your answer. It's very interesting what you are saying. It's okay, you can listen to me, right?
Good.
Okay. Can you share again your slide? Because it's very important what is Nasir asking. Really, it's as Arturo said, a 40% or 0.4, 0.5 OEE is really high, considering that you have to multiply. It's not the summary, it's multiply of quality, raw material, availability, process. So this is very critical. So showing that it's not only machines. You must have machines, a good process, a good formulation, availability of raw material. So when you multiply and you have less than one of some of them, of course, you get less. Moreover, if you have no raw material because of any reason, then it's zero. So we should not confuse with yield of manufacturing. That's something different. We are not talking about a yield. So if you put 100 kilograms to produce and you obtain, of course, 92, 95%, 96%, that's something different. That's a yield. We are talking about OEE, that in fact is how effective you are in your process. And as it's showing again, Arturo over there, availability, performance, and quality are critical. So you should have machine, a correct process, a correct formulation, and material available. So when something like that is not occurring, then you have decreased time process and your speed is decreasing. So that's different related to yield. Yield is something different. Yield is if you put 100 kilograms, if you obtain 98 kilograms, that's the yield. Of course, it's not acceptable a yield of 0.4 or 0.5. That's totally different. So it's something to pay attention really, that the OEE is something critical at your plant, right? So sorry, Arturo, I wanted to.
Okay, very good explanation. And of course, at this time, at this moment of the technology, OEE is a very helping factor for us, and is a key to the selection to choose our machines. Well, so if we say taking apart availability, so pointing attention in the performance, process time factor. Now, in this slide, we will see the speed of unit operation. This is an example, a real, based on a real number, figures, weight granulation tableting and coating. When we want to manufacture 100 kilograms granules to obtain 1 million coated tablet of 100 milligrams. This is our example. So in this slide, with comparison between a conventional production line, let's say a low shear granulation with a double cone tumbling blender, with a static dry dryer, with a oscillating machine, mill machine, and compare with optimized line using the high technology we have today and PAD Group produce. Here we will show you process time for each unit operation in terms of approximately, of course. And here we have the unit operation in order to obtain 100 million coated tablet of 100 milligrams. Wet granulation, drying milling, blending, tableting, coating. So let me show you that the wet granulation could be performed by low shear or high shear, and the drying could be performed by static dry dryer or fluid bed dryer. Dry milling could be at oscillated milling or conic milling. Blending could be by fixed tumbling double cone or tumbling IBC technology. Tableting could be at a conventional rotary oil press or last generation rotary press, and coating could be in a conventional pan, blind pan, or side vented, totally perforated pan. So, of course, this different equipment will have different conditions of the process. For example, I show you one in order of simplicity, but if you will wet granulation in low shear, you will consume 40% of water. Instead, in high shear, you will use 30% of water, less water. Why? Because wet granulation in high shear is very efficient. So you need lower water in order to obtain high quality of granules, and so on. But the important question here is the maximum time that we will use for each of these processes. For example, if you wet granulation low shear or in high shear, this is the difference. Low shear means 60 minutes, at least 60 minutes, in order to obtain a final point, the optimal final point of granulation. Instead, in high shear, you only need 15 minutes and you will have the best granules. In drying, similar. If you put the granules, the wet granules, into the dry dryer static, you will need a lot of time, a lot of minutes. For example, 720 minutes with against 120 minutes in fluid bed dryer. The difference is very big. When you dry milling, if you use an oscillated mill, the time is 4 times what you use in conic mill. This notably. When you blend it, here we have not difference, very important difference. I say equal time, because both double cone and tumbling IBC are tumbling process. So it's very similar. Now in tableting, we compare the conventional rotary press, the old rotary press with at maximum 1,000 tablets per minute, against the last generation rotatory press that produce 2,000 tablets per minute as a minimum, because you could work at 3,000 tablets or more, and this imply a very big difference in time. And of course, the coating in conventional pan versus coating in side-bending pad is, in terms of time, very, very different, in favor of course, in the side-bending pad. When we would add all the times, we note that the conventional line needs, in order to produce 100 kilograms of granules and 1 million coated tablet, we need 2,230 minutes, around 37 hours, against only 13 hours, a continuum process, of course, yes. The difference is very big. So the optimized versus conventional means this saving time. You're saving 63% of the time. The difference is very, very important. So this means that the OEE for each of these equipment, OEE for wet, for drying, for milling, for blending, for tablet, for coating, will be bigger, the bigger possible, and will impact in the saving time of a global process. This is a very important question. Try to produce at high speed is a very important question. This is performance. And after this, well, this is the very same in a figure. You have the time, the global time, and the global time in the other question. But the other question is the process quality factor, means the product quality. Of course, the process never give us 100% of quality. Defects or loss of powder or loss of tablet or etc. reduce the factor quality and the yield. Here we have the optimization line, the relative advantage against the conventional. So here we show you the unit operation to obtain 100 million of tablets. Wet granulation, now high share. Dry granulation, now at fluid bed. Milling at conic mill. Blended at IBC, intermediate bulk container. Tableting at rotary automated press. And coating at the side bended. So this table is very, very dense, very, very large. I tried to show you some of the principal questions, and then you can see it with time. But I want to say you that when you wet granulation, for example, you need lower consumption of solvent. You need less water or less alcohol or less blending alcohol water, because you put more energy, mechanical energy. So if you put high energy, you need less solvent. And this impact in the drying time, because you need to evaporate less solvent. Another question around the wet granulation is the best shape of the particle size distribution you obtain of the granules. The particle size distribution is very important because you have parameters like the span or like the diameter 0.5 that characterize this shape. So the best shape is obtained in high share granulation. Another question, very, very, very important, is in wet granulation, the better API uniformity in the granules, because the API is fixed at the granules, and so will not segregate during the next processes? It's very important question this. Another, of course, when you use wet granulation in high shear, you obtain a granule that have a very good mechanical characteristic. That means you will have a granules with high compactability. High compactability means that then in the tableting process, you will need lower force or lower pressure to obtain a very good hardness. So you protect the tablet machine because you don't need to do high pressure or high force, because the granules don't need high pressure or force to produce hardness in the tablet. In the case of drying in fluid bed dryer is homogeneous drying. In static drying is not homogeneous because the air pass in the surface, and in the case of the fluid bed, the lines of air, of hot air, pass through the bed. So we say it's more efficient. And of course, another question in the fluid bed dryer is no chromatography effect, because there is no migration of API from the layer of the static dryer. In the static dryer, you have a thickness of granules, and the solvent is depurated in the surface, and the API or the AP migrates like a chromatography, and you obtain a segregation. This question is not occur in the drying fluid bed dryer. Another question is you will not have a hot spot because it's very uniform, the distribution of hot air. And of course, another question is easy to load in the fluid bed dryer. It's easy to load from the high shear machine by convection. And so it's an ergonomic question. In the milling, of course, in the milling using conic mill, you will obtain a narrow particle size distribution and will find that the percentage of fines are lower. This is very important. As you remember, if you have a high percentage of fine, the flowability could be affected. And if the powder flowability is low, you will have problem in the uniformity of weight during tableting. So in this case, in the conical milling, you obtain a narrow and a lower percentage of fine. Of course, this kind of machine, less heat development have. You have a very flexibility because you can select the impeller, the separator, the type of conic conic sieve, and you have to change the speed, the RPM, because you use 100 RPM to 300 RPM, if you need, of course. Another question is the high capacity of processing granular in comparison with oscillating machine. Blending is a very important step, of course. We need to obtain homogeneity, uniformity of the components. And we prefer the blending at IBC. IBC, we will see this in the next webinar, of course. IBC means intermediate bulk container. This intermediate bulk container means an equipment where we can blend, store, and use to load the hopper of the machine. So we eliminate one step of discharge. When you use a fixed blender, like a double cone, after blending, you need to discharge in a tank, in a vessel, And in this moment, this discharge could produce segregation. This not occur in IBC process because you put the IBC blender in the top of the machine, or the tablet machine, and connect it with the hopper of the tablet machine. So you eliminate the possible segregation that imply the discharge. Of course, reduce the product handling and a loss, split losses. And another question important, that IBC allow high load of powder. Let's say 70 and 20% of the total volume. About tableting, we said we have to say that the compression force that the sensor measure. Remember, this tablet machine have sensor that detect the force or the pressure. This force lets us the machine measure the weight variation and discard the tablet with higher or lower weight, or the weight or the tablet which weight is out of specification. This is very important because you work with an automation process, and the machine automatically discard the tablet with high weight or with low weight. And this is because the machine measure the force and send information to the configuration of the discharge device and discard all tablet with weight out of specification. Another question is the compression force produces discard. I say this. The ejection force here, the ejection force sensor allows to the monitor to the lubrication status of the punch. Yeah, and this is very important because when we lubricate our powder or our granules with magnesium stearate, we have to have the certain that is good lubricated. So this ejection force sensor will say us that is very is good lubricated the powder, and this will reduce the problem of stop the compressor because the friction, or of course avoid deterioration of the gums at the guys. So force sensor and force ejection are very important in protect the machine and produce good tablets with good uniformity of weight. Of course, if you have the optimal adjustment of the pre-compressor wheels, remember this tablet machine, we will in the next webinar we will point to the tableting process, but now I say that the optimal adjustment of the pre-compression wheels reduce the risk of tablet cupping or lamination. Well, finally, when we coat the tablet at the side-vented machine, well, first of all, high tablet mixing efficiency, because this machine, this coated have a very good mixing of the tablet into the pan. So this means that the tablet will be coated with uniformity film. This machine have a higher drying efficiency, of course, allow a higher coating suspension flow rate. So if we have good flow of energy, we have the possibility to inject bigger quantity of suspension and reduce the time of the process. It's a very important question too. And of course, lower spray drying, so less loss of coating solid in the process. And we have variables just like vacuum and to use different level of weight vacuum into the pan is very important to graduate the quality of the process. This aspect will we try in the last webinar about coating of the tablet. Well, it's in a brief form, in short, the most important aspect in order to introduce the next 5 webinar we will have. But something that I want to say you that the quality of the process and the process efficiency, of course, depend on the technology. The technology is a very, very important factor. But in PAT group, we have the experience and know perfectly that this is not the only question. Beyond technology, the quality and the efficiency of the process also depend on a particular solution, and quality and efficiency of the production need raw material and formula and manufacturing process. Gabriel before speak about some aspect of this, and the solution means selection of raw material, a good raw material. You need raw material in order to produce high quality, purchase, of course, the specification, quality, quantity, composition, of course, formulation tips. In these processes, there are a lot of tips you need to know in order to have the best quality and efficiency, of course, and expertise. And of course, for manufacturing process, we need the best configuration of process of production line, set the process variable, the scale up, specific application, and tip of methodological tips and expertise. This slide is a synthesis of the factor that impact in the final quality and efficiency. It's not only technology, it's technology plus raw material and formula plus manufacturing process. If we could optimize these 3 factors, we will have not only high performance, high speed, but we will have high quality of our product. These are the lines showing in the shims, direct blended, dry granulation, and wet granulation. Well, we will see this in the next webinar, of course. The next webinar are here. Well, it's I want to thank you for attention, and well, I wait for the question you have.
Yeah, first of all, thank you, Arturo, for your clear presentation. It's a pleasure, like always. I think you mentioned many topics that are very interesting. Maybe to remark OEE, I think it's very important, but also you talk about solutions. That's what we provide. In fact, but through thinking about this integration in quality and efficiency, considering not only technology, but also manufacturing process, and raw material and formulation, as mentioned before. So the integration of all this is what will give you a better performance in your development and products. So again, wanted to thank you, and this a message for everybody that is attending this webinar. Want to thank you also all, and okay, we are here to listen to your questions and your requests. Thank you.
Okay, thank you, Gabriel. We have some comments to make. We have a survey that you will start to see right now on the upper right corner. If you can please provide an answer to this survey. Can you see the survey? We have some comments on the corner. Okay. Good. When you complete this survey, we have one more question for Arturo, and then the other questions we will answer by email, as we are already 10:05. And this question came from Nasir, and he says, what is the advisory transfer system if due to a space, client has to shift granules from IBC to compression machines? Please, Arturo.
Excuse me, can you repeat me?
What is the advisory transfer system if due to the space, the client has to shift granules from IBC to compression machines?
Yes, the IBC container, the IBC technology, intermediate bulk product, have a lot of advantage, because in the same vessel we blend, we lubricate the powder, we storage the powder into the stores, and then we can move from the storage to the tableting room, put the IBC with the blending over the tablet machine, and open the connection and load the feed of the machine without produce a discharge, a typical discharge in the fixed blender. So this means that you will avoid the segregation, the natural segregation that produce the discharge from the double cone, the fixed double cone, to the tank or vessel. You eliminate this step. So IBC technology is the best way to blend, storage, and load the hopper of the machine. You avoid the segregation. Is this the response you need?
Nasir, is this question okay for you? Yeah.
No, Mauro, can you hear me?
Yes. Now we can hear you.
Okay. I was just asking that if customer don't have space to use the top-load IBC bins, then what would be, or what can be the ideal method to transfer finished granules from IBC bin to the compression method?
You mean because on the room, on the tablet area, there is no height to have a bin blender on the top, right?
Mm-hmm.
Exactly.
Yes.
Okay.
Yeah. So to make a transport, you mean, because you don't have enough room space to put a IBC
Over the
above,
tablet press.
Yeah, above the
Tablet press
machine. Yeah, you should be very careful on the selection of the way you load the tablet press machine. If you can have a mixture that can segregate during transport, then it's an issue. That's maybe what you mean. Preferably always by gravity would be much better, of course, we will be sure on that. We should analyze, no, Arturo, I think we should analyze the kind of product that we are talking about to define if the transport by vacuum is okay or not, or we can have a segregation of the mixture. So,
yes, the convey, the powder convey, but vacuum is not the best. At least you have a block transfer. Actually, the technology will enhance and produce the transport of block of powder from the storage in a segment and not fluidified. A typical convey in vacuum, you produce a fluidification of the blend. So in these cases, you could obtain segregation because the particles are different in size, different in density, and different in shape. So not the convection must be in block. This technology is in this time is being introduced in this time, but is not universal at the moment. So in order to supply this technology, IBC technology is the best because have another properties. You blend and you store. So blending, storing, and loading the machine are three properties that the IBC give us.
Yes. Now, we have one question for you, Arturo, from Mr. Mugdad. And he says, what factors are affecting the tableting speed from product point of view? What factors are affecting the tableting speed from product point of view?
Yes. Tableting must performance at the highest speed possible. One of the factors that could affect the speed of press, of tableting press, is the composition. When a formula of our product have a high percentage of fillers that have plastic deformation, let's say microcrystalline cellulose, starch, or something like this, this kind of filler present what we call pseudoelastic deformation. Pseudoplastic deformation. Pseudoplastic deformation means that the powder you obtain by dry compression, by wet granulation, by dye decompression, have not only force dependence, but have speed dependence. Because if you increase the speed of rotation of the tablet machine, the time, what this means, the dual time, the time during which the powder is compacted in the station is short. And if your formula has a very high proportion of these fillers pseudoplastic could be a problem that not reach the hardness you need. So you have to reduce the speed. Let's suppose you need to pressing at 3,000 tablets per minute, but your formula have 40% of microcrystalline cellulose. Let's say pH 102. Well, take care, because in this case, perhaps you can't produce tableting at 3,000 tablets per minute, and you will have to use 2,000 tablets per minute. But this is not due to the technology. This is due to the formula. The formula condition the speed of the process. These are the most important aspect when we formulate in the step of development of our formula, the selection of the fillers and the other excipient, of course, and the proportion. Because I say that microcrystalline cellulose is very important filler, of course, but take care with the percentage you use in the formula, because this aspect could limit the speed maximum, the maximum speed you could use in the tablet of last generation.
Thank you very much, Arturo, for explanation, and thank you everyone for joining for this first webinar. As I said before, we will share with you the presentation, and then you will see also this record in our YouTube channel in around 10 days. So the questions that we do not answer, we will do it by email as a limitation of time, and hope to see you again in 14 days. Yes. Thank you very much, everyone. Take care. Thank you, Arturo, and thank you again.
Thank you a lot.
Thank you.
Thank you, everyone. Thank you.
Bye. Bye.
Thank you. Thank you, everybody.
Thank you, Ron.
Thank you, Raman.